This question is about some group 7 compounds. State what is observed when silver nitrate solution is added to sodium fluoride solution. Okay, so with this, obviously these are the precipitate reactions, but if you remember, solubility increases up the group, and the white precipitate of silver chloride is soluble in dilute ammonia, and then silver bromide in concentrated ammonia. So what that means then is this will be just soluble in water, so there'll be no observable change here. Let's get the right pen on. So no observable change. Okay, solid sodium chloride reacts with concentrated sulfuric acid. State one observation when solid sodium chloride reacts with concentrated sulfuric acid. Give an equation for the reaction and then state the role of the sulfuric acid. So this is the one that isn't a redox. Okay, so what you get with this then is white or misty fumes. And the equation for that, NaCl plus H2SO4 goes to NaHSO4 plus HCl. An alternative equation for that would be 2 NaCls with H2SO4 goes to Na2SO4 and 2 HCl. And the role of the sulfuric acid in this, it behaves as an acid. Okay, so this is not the redox reaction. However, this one is. Okay, so fumes of sulfur dioxide are formed when sodium bromide reacts with sulfuric acid. So if you remember, sulfuric acid, it can keep going to sulfur and then to H2S, but bromine only goes as far as this. We've gone from +6 to +4. So this is the redox reaction. And of course, that has been reduced. So the equation here then, I'm going to have to kind of do this in stages. So sulfuric acid forms SO2. So balancing the redox, then I need 2 waters over here to balance the oxygens. And then I need 2 hydrogens over here to balance out the hydrogens in water. And then I need 2 electrons in there. The iodide forms iodine, 2 electrons here. The electrons cancel out, so the equation, I just need to combine these 2 equations as they are. So 2H plus SO42 minus plus 2I minus gives I2 plus SO2 plus 2H2O. So observations here. Sorry, this is bromide, isn't it? Dear me. Same reaction, but just with bromide and bromine instead. Okay, so the observations then. So the obvious one here is the bromine, which means I'm going to have a brown or orange gas. So observations are what you see, and I'm sure some of you will have written that you get a choking gas. That is not what you observe. Okay, so an observation is what you see. So brown gas or brown fumes or orange fumes. Or something along those lines. And then the role of the sulfuric acid then. So if the sulfuric acid is itself reduced, then that makes it an oxidizing agent. Okay. Next question. Give the equation of the reaction of chlorine with water to form a solution containing 2 acids. So this is the disproportionation reaction, which you either know or you don't know. And then explain with reference to electrons why this is a redox reaction. So I've got to make sure that I'm doing the reactions in here. So one of the Cl's in Cl2 forms HCl, or probably more accurately Cl minus in there. So Cl minus, therefore gained electrons. Okay, remember a reference to electrons. And then the other Cl in Cl2 forms HClO. This has an oxidation of number of +1. Therefore this has lost electrons. Okay, and then a student adds chlorine water to a solution of sodium iodide. So again, state the observation and give the ionic equation. Start with the ionic equation, probably easier to work this backwards. So chlorine plus 2I minus gives I2 plus 2Cl minus. So we're forming iodine. The colour of iodine that we're going to use then is a brown solution. And then F, use your understanding of the electron pair repulsion theory to draw the shape. Include lone pairs that influence the shape and explain why the ion has the shape you've drawn. So we need to explain it, and then we need the bond angle. So OF3+, so let's start with, so oxygen is in group 6, has 6 electrons in its outer shell. I've got fluorine, which brings 1 electron each to the covalent bonds, and I've got 3 of them, so that's going to be 3. And then a plus charge, I need to take away 1. So 6, 7, 8, 9, so that's going to be 8, which is going to be 4 pairs. So the parent shape of this is going to be a tetrahedral. That's the pair. That's not the shape. That is just the shape that it is based upon here. So that's going to give me that there. Now I've got 3 bonding pairs. So let's do the count here. So 3 bonding pairs of electrons and 1 lone pair of electrons. Okay, so let me rub that top one out there, make that a lone pair, and then put my fluorines on all of the rest of them here. Okay, so lone pair electrons, repel more than bonding pair electrons as they are closer to the central atom. Central atom. Obviously don't abbreviate that, I've just done that because I'm running out of room. So tetrahedral will be 109.5. We take 2.5 off per lone pair, which gives a bond angle of 107 degrees. So I'm just going to go back and check that I've done everything. What I do find is people underline things but don't actually check off what they've done and still miss it. So lone pairs, I've done that. Explain, I've done that. Bond angle, I have done that as well.